So you start with topic. You can call it build a function to model relationship between two quantities. Two quantities. Okay, so that's the main thing we are going to accomplish today. All right. Now recall that in I think two previous classes or even the last class, I asked you to give some examples of what you consider to be a model, what you consider to be a function. And I asked everybody what they wrote, and then you gave me a bunch of stuff. So now some of those things we are going to actually use today. All right. So now, but let me start with an example of some kind of two quantities that we can relate to, and then we will see how to build a model out of it. So let's start with example one. Example one. So let's start with U.S. population, United States population, U.S. population. Okay. So now I want to ask something about U.S. population was done recently. What was it? Who can remember? Who can think about it? Something that relates to U.S. population. Yes, Narisha, you wanted to say something. Go ahead. Something about United States population.
Census?
Yes, the census was done recently. And I believe all of you know the reason why the census had to be done. Can somebody explain to us why the need for the census?
So you can reevaluate the representatives in the House.
Okay, that's one of the reasons. Another reason, please.
I believe it helps with district, I think it's called gerrymandering or something like that, when he puts the lines in, like, for example, schools where students go in schools because of the population.
Okay, so it helps in districting or redistricting. Okay, that's one example. Another example, thank you. Another reason, yeah, go ahead. Another person, I need as much reasons as possible. Why the US population? Why census? Why did they have to spend a lot of money in doing the census? Okay, that's another great reason. One more, let's go one more, then we'll move on.
To track population growth?
Yes, to track population growth. That's another major reason. As a matter of fact, that's actually number one reason. To track population growth or even population decline. Because in some places the population grows and in some places the population declines. So now with respect to the general US population, it is reasonable for a country to say there are so many number of people in this country. Okay, guess what? How many do you think? What's the population of US right now? Guess, you can just give me a guess. It doesn't really, I don't need accurate answer. Just, what do you think?
300 million.
Okay, somebody said 300 million. Another response, please? Not up to. Okay, it's within the neighborhood of 300 million, but it's probably about 330 million people live in the United States right now. 330 million, just about that, or it could be more, plus or minus. 330 million people are in the United States. So now all those reasons you gave are very important. So, but to track population growth. So now let's create a little table that shows the population of United States every year from a certain time to a certain time. So let's create a table. So right here we are going to draw with me, please. We are just going to write the year and then the population in million. Okay. We are going to write the year and then the population in million. So we are starting with year and then population. So this is population. Okay. So now let's start with 2008, 2008, 2009. This is 2010, 2011, 2013, no, 12. Then 2013, 2014, and probably 2015. So we starting with year, and then the population we can say is in 2008 we had 304 million people. In 2019, no, 9, we have 206. No, I'm sorry, 306 million. All the numbers I'm writing below are in millions. Okay, so we have 309. We have 311. We have 314. We have 316, and we have 318, and probably 321. Okay, so this is the population of United States from 2008 to 2015. Okay, all right. Now, if you have this type of numbers, remember each state gets their own population too. Maryland, New York, California. So when you add up all these states, that's how you get the national figure. So this is 2015. Now, it is possible for us to analyze this information we have now by plotting a graph. You know, we're plotting a graph of year and what? We are plotting a graph of year and population, year against population. Thank you. So you can just sketch a quick graph, sketch a quick graph of this particular figure. And so you can have, we are just sketching. We're not really drawing something accurate. So we are just trying to sketch to see how it could look like. Okay, so you can have just 2008, 9, 10, 11, 12, 13, 14, 15, and then you keep going. And then remember, these things are in millions. So you can have maybe 300 million, and then you can have 305, 305, 310, 315, 320. And on this side is regularly that's your y-axis. This is your x-axis. But in your x-axis, it is representing year. It is representing year, and then the y-axis is actually representing population. Okay, so now you can just quickly indicate what you have. Remember, when you are drawing an x-y axis, you still have the negative section. So in 2008, you have something like 304. So 304 is probably somewhere here. And in 2009, you had 306. I'm sorry, 304 is somewhere here. So just sketch something. So then in 2009, you have something about somewhere here. Okay? And then you keep going. 2010, you have 309. 309 is somewhere here. Remember, we are just sketching. You can draw a better graph using a graph paper. And 11 will give us 311. So we have somewhere here. And 12 will give 14. 14 is somewhere here. And 13 is 16. 16 is somewhere here. And 14 is 18. 18 is a little bit closer to this place. And 21. 21 is closer to this place for 15. See? Now, having plotted your points, then you can just join the line. You can just join the line. You may not get a perfect straight line due to the population, but at least you can draw what is called line of best fit. Line of best fit. A line of best fit that cuts across the points in between them. Now, at this place, you have a y-intercept, right? So based on this, based on what we can see, we can conclude that this is a linear model. True or false?
True.
True. So now we think about what's the general relationship for a linear function. So a general relationship for a linear function, is y equal to mx plus b. All right. So in this case, You see, every x is the year and y is the population. All right, and then you can see at this point, this is where you have your y-intercept. So this is basically around maybe 280 million people or something like that. 280 million people. Now, so let's just make an approximation right now that this is B is 280 million. And that y-intercept, no, not this is y-intercept, 280 million. And then the slope. So all you need to do is pick 2 points, probably this and this, and then you determine your slope. How do you determine a slope? By using the slope formula, which is m equal to yes, rise over run.
Y2 minus y.
Yes, y2 minus y1 divided by x2 minus x1. Or you can say rise over run. Rise over run. All right, which one works best for you? So now let's just make an approximation right now and say that the slope of this graph is, you can say it is 2.4. This is just an approximation. All right. And then, of course, the x-axis is the year. You can either call it year or you call it time. It doesn't really matter. So you can call it time. And then this is the population. Population. Now we have successfully modeled. Of course, these coordinates are something like 9,3 whatever that this point is. Probably 306, something like that. While here is, you can actually pick the point from here, from the table, and you can pick the points from the table, the 2 coordinates, and use it to get your slope. All right. So from what we just did, we can come to the conclusion that the population of United States grows at the rate of 2.4. And of course, we started with a given number every single year. So you can come to that conclusion. So when the politicians, those who run the government, when they tell you that in so year, that so thing, the population is going to be so number, this is the type of thing they do. They can tell you that in 10 years time that the population of United States will be 350 million. And they will say the population of Prince George County will be so number. They will give you a number and they will be near accurate because they just use some mathematical model. And they use that plan. Once they make that plan, they use it for development. They use it for redistricting. They use it for so many other things. You see, now the politicians who does the redistricting, they don't go about house to house scouting people to know how many people live there. They just run this type of mathematical models. Any questions so far? Okay. If there's no question, we can consider another example. Now, let's talk about hourly wage. You know, somebody works per hour or is paid every per hour. And so you can have 4 days of 4 weeks in a month. So you can have 4 weeks in a month, or even daily. You can do all these things in daily or weekly or even yearly. It doesn't really matter the time period. So somebody works and is paid per hour. My electronic writing tablet, I don't know if it's faster than my hand or what. Okay, so let's just consider weekly payment. Number of hours per week, you can call it hours and you can call it pay. So maybe first week, second week, third week, fourth week. So now this person works the first week, probably the person works 30 hours. Second week, the person's hour is increased, 32 hours. Third week, the person's hour is increased maybe to 36 hours. Then the fourth week, the person's hour is increased to 40 hours. You see, this type of thing. And that is called direct variation. So now, if you don't want to say If you don't want to say it the same way I just said, that payment received is directly proportional. If you don't want to use the word directly proportional, you can use another phrase. If you don't want to use directly proportional, you can use another phrase to say that you call it varies directly. You can say payment varies directly as hour. That's another way you can phrase it, and it will be technically correct. Any questions so far? Okay, so now if there's no question, let me give you one. Okay, let's just solve one problem about direct variation, and then we'll see how it is applied. Okay, look, listen to this. Listen to this. In Maryland, the state income tax is directly proportional to the gross income. In Maryland, the state income tax is directly proportional to the gross income. If you work in Maryland and your state income tax deduction is $46 for a gross monthly income of $1,500, find a mathematical model that gives the that gives the state income tax in terms of gross income. You see, so income tax, you can say tax varies as income. That's where you start. It means tax is equal to constant multiplied by income. So if, for example, let's see, hold on. Okay, so if you are being deducted every single month, they take let's say $50. If you earn a gross income of 1,500, K equal to times 1,500, 150. So you make, let's say you make 1,500 and then they take $50. You make every 1,500, they take $50. I'm just making up an amount, okay? So now what will be the K? What will be the K? Which is the constant of proportionality. So the K is going to be, if you divide both sides by 1,500, you are going to get 50 over 1,500 equal to K, okay? So you can simplify that. And that is going to give you 1 over 30. So which is, K is 1 over 30. So now, using this, you can generally model that the income tax collected from somebody will be represented by T equal to 1 over 30 multiplied by the income. So if somebody earns in 1 year, if somebody earns, let's say somebody earns $100,000 in a year, so how much will be the tax that will be collected? So if the income is 100,000, if income is, maybe let's just use is $100,000, how much tax would be collected? How much tax will be collected? Quickly, ladies and gentlemen, quickly do it in 2 minutes. Actually, 1 minute. Okay, this time around I'm going to call names because some people don't feel like sharing stuff, and in education you have to share. Mikael, go. What would be the income? Did everybody see this formula that I wrote here?
I got it.
Okay, that's what you need. Yeah, Mahmoud, go. What would be the income?
So
Now, what would be the tax rather?
I got $3,000 and 333. Wait, $3,333.3.
Okay, so what did you do? Tell us, please.
I did 100,000 times 1 divided by 30. 100,000 times 1 over 30.
Okay, and that's your process is 100% correct.
Yes,
The
sir.
process you just explained is 100% correct. So now you see, we have just developed a formula. And guess what? This is the kind of thing that Maryland uses every single day, including Prince George's County. When they are deducting taxes from you, this is the kind of thing that they use. There is a mathematical model. They have already, by law, they have already said, if you make a certain a certain amount of money, that they are going to deduct a certain amount of money, and then they model a mathematical relationship. So every single week that you make some money, they use the same model, and then that's how they deduct all those things that they deduct from your paycheck. I don't know how many of you that are working, but if you've never worked, that's fine, but ask your parents how much that are being deducted from their paycheck every week or every 2 weeks. Ask them. You can hear what they tell you. This is the type of thing they are using, nothing else. There's no other magic that they are doing. And they code this type of thing, they code it on the computer so that each time the amount of money you use that you make, all they need to do is press one button, and it will tell them how much they are going to take. And they will take it automatically even before the money gets to you. That's direct variation right there. All right, so now before I give you the work, let me do this solution. So we are going to use the formula C equal to 1/30 multiplied by I. And it says if income is 100,000. So we have C equal to 1/30 multiplied by I, which is $100,000, and that will give us what? What's the figure again, please?
33,333.
Is it 3,300 or 33,000?
33.
Okay, 30. It cannot be.
It's 3,000. 3,333.
Okay, so it's 3,333. Okay, that's the tax they are going to collect if they use the model that we just described. All right, now let's see. I'm going to give you a direct variation again. So I would say find a direct variation and model that relates Y and X. Find a direct variation that relates Y and X. So this is task. Find a direct variation that models. I'm sorry. I'll take it back. Find a direct variation model. Find a direct variation model that relates Y and X. Y and X. So for example, example A, if X is equal to 2 and Y is equal to 14. And in another example, if X B is equal to 4 and Y is equal to 8 pi. So create the model.
Mr. Cable, is that a 4?
Yes, this one is 4. This one is 4. That's why I kind of miss my blackboard. That should actually do it for the day. So let me create a Google Classroom task, and then you can upload your solution there.
Could you scroll up to the top where it says topic? Because I didn't copy that part down.
Yes. Build a function to model relationship between two quantities. Okay. So now I need to quickly create this before it's too late. Let me get back to right now. I'll just call it build a function.
Mr. Okabu,
Yes.
is that a pi next to the 8?
Yes, that's 8 pi. That's 8 pi. Okay, now, ladies and gentlemen, while you are doing this, just give me 1 second. Let me make this quick announcement. Now, this work is supposed to be easy, and you should finish it within 2 or 3 minutes. However, please, I am begging you or appealing to you, do not let it go by the due date. Here's the problem I'm getting. If I start scoring after this class, I may decide to grade the work immediately. Once I grade the work, I will grade those who submitted the work. And then once I grade them, I will enter it into school marks immediately. Once I enter it into school marks, any other person who submits work, that will be late. And I cannot predict when I will get back to the school marks in order to record or grade late work. I cannot predict that because there are so many other things that I'm doing. Do not expect me, you submit work late and then you want me to enter the grade immediately. It doesn't work that way. here's what I have to do. Once I'm able to enter grade, like we meet basically 3 times in a week for the most, or for sometimes, or even 2 times a week. Once I'm able to enter 2 grades in a week, I have fulfilled the obligation. So if you're bringing work later and you're expecting me to be entering the work once you bring it, no. I may go back and enter it later on. And even if I don't enter it, you have a recourse, which is called grade appeal. I don't think you want to go through that process, because that means you have already failed before you start appealing for grade, or your grade has already dropped to something you don't like before you start appealing for it. All I'm asking you is make sure you meet the deadline. If you come to class, I try to make the work easy for you, so that all the information you got from me becomes most of the work you have done. Okay? Once you upload your work, you can exit. The class is over.